Okay, I want to do something that usually students find kind of difficult with any topic. I want to make a comparison. What we've got is we've got two identical setups. I've got a mass rotating around and a mass over here rotating around. We'll call one A and one B. The radius of the circle for both of the circular path is the same. RA is equal to RB. And the masses are identical. MA is equal to MB. The only difference is that the period for A and the period for B are different. Period for B is 1/2 of the period of A. I always found it tough to work with like the A's and the B's and in the variables. So what I like to do is pick a number. Nice easy numbers. Because we're going to go ahead and we're going to stick this into the equation. So let's say that these guys are both equal to 1. 1 what? Does it really matter? 1 unit. You know, we could call it 1 meter if we want, but really it's not, you know, the unit doesn't matter. It's whatever unit it is. Same thing with this. We're going to make that 1. I'm going to make this 1, which makes this 1/2. So first comparison we want to do is we want to see how the velocities compare. Well, velocity centripetal or circular speed, whatever you want to refer to it as, is equal to 2 pi r. I really don't like that pi. Let's try this again. 2 pi r over t. So in this case, if r is 1 and t is 1, that means that this is 2 pi, right? Because this is 1, so I wind up with 2 pi. Over here, I've got that same thing, 2 pi r over t. So I'm going to put in 2 and pi, and I'm going to put a 1 in for the r, but the t is going to be 1/2. So I wind up with a 2 in the bottom of the bottom, so that's going to go to the top, and I wind up with 4 pi. So how do the velocities compare? Well, velocity for B is greater than velocity of A. In fact, it's double the velocity. B is double. So how do the accelerations compare? Well, we're going to do the same thing with the acceleration equation. That's going to be v squared over r. In this case, that's going to be 2 pi squared over 1, which is going to be, because my radius is 1, which is going to be 4 pi squared. Over here, I'm going to do the same thing. That's going to be 4 pi squared over 1, which is going to be 16 pi squared. Well, acceleration of B is going to be greater than acceleration of A. In fact, acceleration of A, I should make that the same A that I was using. Acceleration of B is quadrupled. What does that mean? 4 times as great. Right? Because 4 times 4 pi squared would give me 16 pi squared. All right, last one is, how do the forces compare? So let me go ahead and see how the forces compare. Again, I'm going to put the equation in. Force centripetal is going to be equal to mass times acceleration centripetal, which is going to be 1 times 4 pi squared, which is going to give me 4 pi squared. And over here, it's going to be 16 pi squared times 1, which is 16 pi squared. So it's the same as what we did for the acceleration. So force centripetal of B is greater than force centripetal of A. In fact, Fc of B, again, is 4 times as great. In other words, it's been quadrupled. That's probably the easiest way to make comparisons like this, or when something changes. You know, if I said that originally the period was 1 and then we changed the period to 1/2, keeping everything the same, I would just set up two conditions like this and work through the problem, picking some very simple numbers for my variables so I could make some comparisons like this so that I can plainly see how that affects the quantities that I'm trying to compare. Okay. Again, that's probably the easiest way to do it. I found that to be easiest when I was, learning physics back in high school and college. I guarantee there'll be something like this on tomorrow's test. Guaranteed.